Hi, welcome to Upward Bound Algebra Day 5. Today we're talking about factoring and solving quadratics. So today we're going to cover factoring, solving by factoring, and then the quadratic equation. When you're given an equation that looks like ax squared plus bx plus c, that's a quadratic. And the first thing you look for is common terms or monomials. In this example, notice that each term has an x and a y. Take that out first and then see what you have left. So when you have 3x squared y cubed and you take out one of the x's and one of the y's, like dividing with your exponents, it leaves you 1x y squared, so 3x y squared. Second term, 2xy squared, taking out x and y, leaves you with 2y. And 3x squared y, taking out 1x and 1y, leaves you with 3x. Now the rest of this cannot be factored. If you could factor the rest of it, you would, but you can't. When you factor binomials, you're looking for the difference of squares. So difference of squares is two perfect squares being subtracted. That will always factor in the format of x plus y, x minus y. Then you have two patterns for sum and difference of cubes. When you have two perfect cubes being added, they will factor in this format. When they're being subtracted, they will factor in this format. Then you have to figure out how to factor trinomials without a. X squared plus bx plus c. The a is 1. Ask yourself the question, what are the factors of c that do the second sign to get b? So in this example, what are the factors of 5 that subtract to be 6? The answer is 1 and 5, but both of them would have to be negative, and then you would build your parentheses. X splits in half, x squared splits into x and x, and then the factors that you came up with, minus 1, minus 5, go into your parentheses. Sometimes you're given a 4-term expression that needs to be factored by grouping. Like terms together, factoring monomials, then having binomials that match, that can also be factored out. So looking at this, notice the first two terms have a 3 and an x in common, and the last two terms have a 4 in common. So if we're going to factor that monomial out, we take a 3x out, and we take the 4 out. Then notice that the parentheses we just made match, and we would take those out. So it would be the matching parentheses times what remained. When you go to factor a trinomial with a, meaning with a number out front, this is a little more complicated. You ask you want to get the factors of a times c that again do the second sign to get b. So what are the factors of 24 that will subtract to get 5? And the answer is 8 and 3. We need a negative 5, so that's going to be a negative 8 and a positive 3. So option 1 is to write it as 4 factors now, and then factor by grouping. So that would be to write the minus 5x as negative 8x plus 3x, and factor by grouping. That's one way to factor it. Or you could do this. You write the pair factors of a, okay? and the pair factors of c. And what you are trying to find is a combination of those being multiplied and subtracted to get a -5. This one's a little more complicated. If a quadratic is set equal to 0, then the factors, one or both, must equal 0. Factor and then solve the factors to set it equal to 0. So the first thing we're going to look at is the difference of squares. X squared minus 9 would factor to be x plus 3 times x minus 3. When that equals 0, that means that either the first term, x plus 3, or the last term, x minus 3, has to equal 0. Solving that, we get x to be -3 or +3. When you're factoring without a, you do the same thing. What are the factors of 12 that add to be 7? That would be 3 and 4. They're both positive. Setting those equal to 0, x would be -3 or -4. Sometimes you get a quadratic that you just can't factor because there are no factors of 6 that add to be 2, right? Here we have to use something called the quadratic equation. The quadratic formula says, to the tune of Pop Goes the Weasel, x equals -b plus or minus square root b squared minus 4ac all over 2a. So let's look at an example where we're solving a quadratic equation with the quadratic formula. If you're given the equation 2x squared plus 2x minus 3 equals 0, the a is 2, the b is 2, and the c is a -3. So when you plug that in, sorry about the typo in here, you would use opposite of b, -b, plus or minus the square root of b squared minus 4 times a times c. That should be a -3. So that you have -2 plus the square root of 4 plus 24 over 4. That's -2 plus or minus square root of 28 over 4. The square root of 28 is 2 square roots of 7, which then can be reduced by taking 2 out of each term to -1 plus the square root of 7 over 2. Thanks for watching.